After nearly 40 years of building products for the phosphate mining industry to reduce costs primarily of parts that would wear out in plant and in the mining operation, we saw a real opportunity to be able to help our customers reduce one of their most significant costs, the cost of pumping the ore into the plant and the tailings away from the plant.
We've been enhancing materials for applications in pump parts for the 50 years that we've been in business, whether it be in alloy or in our counterpring, to give better performance and longer life throughout the world.
One of the most demanding pumping applications found in mining is pumping of matrix from the dragline pit to the beneficiation plant, or washer as it's known. Pumps in that application have to be able to pass up to a 9-inch particle size. Pumps there have to handle 40 to 50% solids concentration and long line lengths. We're talking about overall pumping distances sometimes that reach 15 miles with pump spacing perhaps every 4,000 to 5,000 feet. Those types of applications require a tremendously well-designed and engineered pump that will perform day in and day out with low maintenance and low cost of operation. To do that, one of the premier and foremost pump designers in the world, Mr. Urs Blattmann, was able to incorporate the technology from his experience as well as our material know-how into the most effective pump design the phosphate industry has seen to date, the UBD pump.
The pumps being used in phosphates were traditionally a conventional dredge pump design. Most of the pumps were a standard 3-vane design with semicircular volute profiles, typical of some of the older designs that have been around since before World War II. In those days, manufacturing technology hasn't advanced or wasn't advanced far enough yet to allow the production of complex shapes as far as castings are concerned, molding and what have you. So the ultimate end product was always a compromise. Now with all the advancements in foundry technology, CAD, CAM, three-dimensional modeling and what have you, it allows us to produce patterns, wooden patterns, production patterns, epoxy production patterns, metal production patterns that have shapes maximized for pump efficiency while still maintaining large particle capability. So with the new foundry sands that we have, with the new heat treatment facilities that it's all computer controlled, it makes everything just where a designer, a pump designer, there's really no more limits. You don't have to compromise on your design anymore. And we were fortunate to work with a lot of the people down in the field who have been in the mining industries for decades and decades and really know the ins and outs of what's going on, because there are so many variables when you're talking designing a pump for actually pumping solids in the field with varying conditions, varying ore deposits, varying levels of clay content.
With new technology that was available, Urs was able to design and develop a pump that incorporated a recessed impeller and liner which minimized recirculation and extended pump life significantly.
The efficiency of the UBD pumps or any other pump is really a function of its geometric design, how the geometric design is matched to the actual operating criteria. And in looking at that, one has to look at velocity distributions within the impeller, velocity distributions within the casing, so they all have to match. Fluid enters the pump at a given velocity, which is depending on the flow rate, gallons per minute, in a given size area. So we need to have a smooth transition of velocities as the fluid enters the impeller, exits the impeller, enters the casing, exits the casing. So all of the areas and angles and approaches of the fluid within the confines of the pump have to exactly match. If they don't, That creates turbulence. Turbulence creates wear. Turbulence also results in a reduction of efficiency. So when you have like an old style pump design again, where one does not look at these interactions within and just takes an existing pump design and just adapts it, you may wind up, or you more likely will wind up with a product where the fluid has sudden accelerations, sudden decelerations within the volute, the casing, the impeller passages, and therefore it creates a lot of turbulence wear, and consequently the pumps are very inefficient. The other thing we need to look at is to not only do we want an efficient pump when we start up, we want to maintain that efficiency as long as possible, because in slurry applications, the pump components, the impeller and casing, start to wear. So as that wear progresses, efficiency deteriorates. Now we can design a pump to maximize the efficiency for a longer period of time by shaping it properly to where the wear rate of the veins, for example, and the cut water are reduced, so the efficiency can stay up over a longer period of time, and that in the end will result in sustained power savings to the customer, which lowers the overall cost per ton. So that is one of the keys to the success of the UBD is our impeller design, the velocity distribution, the wear rates, the length of the veins, and the matching volute to go along with it. And that will lower the NPSH characteristics of the pump, which means that the pumps will prime easier, and that is a primary concern in the field because they are operating on a pumping system that has a primary pit pump that has to elevate the slurry from anywhere from 6 to 8 feet.
Our unit typically will be over 3,000 to 3,300 feet before you ever have to make a pit move. The other manufacturers, they typically make pit moves at 1,500 feet and at times less than that.
We have not only been able to improve the overall wear life of the pump by improving the hydraulic design and to match the customer's requirement, but also to improve the wear life so that the maintenance intervals that are scheduled in most mining applications can be adhered to. There are some subtypes of the UBDs depending on the materials of construction, where we have urethane lined shells rather than all hard metal shells with urethane suction liners. Some have urethane impellers in it for tailings and GMT services.
After successfully developing the UBD wet end for use in phosphate mining, our customers realized that one of the weak links became the bearing assembly itself. Urs Blattmann was able to incorporate a new design. This new bearing assembly had a triple seal on each end of the cartridge and also incorporated a new impeller release collar. This enables our customers to be able to safely remove the impeller from the shaft. Once completed, the bearing assembly goes through a rigorous 72-hour testing and break-in process. This gives our customers the assurance that our bearing assemblies will be trouble-free from installation and throughout the life of the product.
After entering the market with the UBD tailings, matrix, and the pit pumps, the customers said, hey, what can you do for us in our water booster pumps? Well, we took a look at what they were running, and they said, look, we got a high cost, we've got inefficient pumps, we're not getting but 250, 60 PSI at the pit nozzles. What can you do? Well, we came back, sat down, looked at what we could do. We built a 50-inch impeller to go inside of the 46-inch UBD pump. And at this time, those water booster pumps are putting out between 285 and 305 PSI, which incorporates a better spray nozzle to bust the product up in the pit so that they can pull it through into the first pit pump to go down the line with a heavier solids than what they were able to without the pressure.
After more than 40 years of manufacturing products for use in the phosphate mining industry,
we're always working with ways to improve
the product that we make.
It's going to run longer,
parts last longer,
so that you're able to work on other items throughout your operation.
will perform day in and day out,
It's going to cut your cost per ton,
easy to work on,
and it's going to outperform anything that you've got in your operation today.
and beyond that, all of our parts are made in the USA.